Hey guys, this is Dhruv and welcome to Conscious AI. So for today's video, we have trained a deep learning model using the CNN Architect and TensorFlow library for the MNIST dataset. Now this dataset consists of the handwritten digits like this, and model's work would be basically to predict the number which we humans have written, not accurately all times, but we have managed to get an accuracy of 94%, which is not bad, keeping in mind that we have only trained a small model here with only one hidden layer. I'll get to the details later. So let's get started. Firstly, importing the dataset from testflow.keras.dataset, MNIST, separated the train and test dataset and loaded it. So in this video I just go through this code, and this is just an overview of the code. For the detailed explanation I'll just go on with the next video for that. So this piece of code is just to check whether we are using the GPU or not, and it seems that yes, we are. Now next is we are just inspecting our data to just know our data better. Now the key here to solve the deep learning and machine learning problems is to understand the data properly. So by this step we come to know the dimensions of the training data, which is 60,000, 28. This is the size, and 60,000 rows basically. The number of samples in a training data 60,000. Also the label same, and the test data is of 10,000 and 10,000 labels for the test data. Okay, so let's go through it. Firstly, CV2 NumPy matplotlib. Basically I have created this function so that I would not have to write this piece of code again and again. What this function does, basically, title of the image and the size. You can change the size, of course. Now this here converts the BGR image to RGB image, so that we won't have to write this piece of code again and again for each sample of our training data. And then again we have just randomly picked 4 of our training samples here. You can see that, just to inspect the data. Next, pre-processing our data. Now this step is very important because your model's performance is based on the data you have trained on it, and the data, how well the data is determined by this step. Firstly, rows and columns, extrain 0.shape 0. So the first sample of the training data, in which the first value of the training data would be the rows, and of course second would be the columns. Here we are increasing the size by 1, just so that it would be easy for our model to interpret it. Basically this is it, and this we are just normalizing it by dividing it by 255, because the value of each pixel ranges from 0 to 255. If we divide it by 255, the value ranges from 0 to 1, which is, again, we are scaling our data here. Basically this step is very important for the ease of the process, because it will just load off from the CPU. Next, one hot encoder. We are using one hot encoder to encode this training data, basically 2 categorical values. Just a simple step, not much complicated. The number of classes, yTest or shape1, which is 10. So yTest dot shape1, which would be this 10 number of classes, definitely from 0 to 9, as simple as that. This is the array. Now building the model. This is the most important step. We have to build a model. So I haven't done any extraordinary hypertuning or something like that, but you could always try that to increase the accuracy of the model. Here for the optimization we are using SGD, which is sophisticated gradient descent. We'll just quickly go through it. I'm sorry, my kernel just got disconnected. Okay, perfect. So activation ReLU, this is the first layer. Input shape is equal to the input shape, which is here, image, rows, column, rows, and 1. Next, this is the hidden layer with 64 corner filters, 3x3 filter size, and the activation is ReLU. Perfect. Now next, the max pool layer with a pool size of 2x2. Next, the flatten, the fully connected layers, and the softmax layer with the number of classes, which is 10 from 0 to 9. And this is a softmax layer because it's an output layer. Now the model dot compile loss categorical cross entropy, simple optimizer SGD with a 0.001% of learning rate, and matrix is equal to accuracy. This is just for the accuracy thing. Print model dot summary. This is the summary of the model. You will go through it. This has a number of parameters here. So the thing you have to note is this is a small model, still we are having so much of parameters. So just imagine a large model like ChatGPT. How many number of parameters will it have? In billions, right? So the training model comes here, which with a batch size of 128. We'll just limit this batch size to 128 because this is the most appropriate one. The epochs here will be 25. So I am doing this. You could increase the epoch or just decrease the epoch. You could just experiment with it and see how it affects the accuracy. You could just play around. Now we'll check the history here. So the history is firstly the model dot fit with the batch size of the batch size. Next to imagine epochs is epochs verbose 1, validation is equal to x test and y test. Perfect. So all this done. Score model dot evaluate x test y test over 0. So we'll print loss and accuracy on the bottom, which is loss here. So we have started with a loss of 2.13 and ended with a loss of 0.17, which is a very good thing. And the accuracy of with accuracy of 55% and ended with an accuracy of 94%. Again, a remarkable thing here. So this is basically a model's history, the loss thing and the accuracy thing. See, this is the loss one, this is the accuracy one. We'll just see again what's the shape of our test data. 10,000 images with a size of 28 rows, 28 columns, and 1 for the ease of the model. We'll just mount our Google Colab, or I'm sorry, we'll just mount a Google Drive here. We'll save the model, and we'll also use the model further to predict the data here. Now my most favorite part, which is the predicting the data here. Now what is this thing? np.argmax. Now this thing, now what happens is how our model returns the predicted value is an array list. Now if the number is 3, basically now 0 1 2 3, which is the fourth one, so the fourth value of the array which would be the highest. So this has to return the highest value of the class which it has predicted. Basically this is it. Now if we'll see here, input image, for the input image we'll take x test, the 32nd value of the x test, and we'll see the prediction, which is here print pred, which is 3. Perfect, it has done the job right. And also the type, it is an numpy array, and the length of it is 1. Definitely we could just play around and let's see 114. What that means here is 7. So it has predicted 7, which is pretty good. One more thing, 1 1 2 3 6, it has predicted 6. So this model is doing great. This is a simple deep learning CNN architecture I have shown here, and I'll also list down the code below. You can check it out there on my GitHub account. Basically this is it. Thank you for watching, guys.